Next question is that find the marginal probability mass function of x and y. The marginal probability mass function of x is already given. Probability of x equal to 0 is 0.5. So the marginal probability mass function, the probability mass function suppose of x. So actually it is given, but from the joint probability mass function also we can check it that whether we are computation correct or not. So we can find px of xi. So px of xi, here only two possibilities, px of 0, that means probability that two possibilities 0 and 1, x equal to 0. This will, we have to take the sum of the other variable. So joint probability mass function, this is xi, it is 0, and then you have to take the value of other value yj. Yj can take value only two value, 0 and 1. So this is nothing but pxy of 0 0 plus pxy of 0 1. So basically if you take the row sum, pxy of 0 0 0 1, so this is coming, if you take this sum, this is 0.5. so this is nothing but px of 0, which is probability of x equal to 0. Similarly, if you take the row sum of this second row, so then you will get, so here also it is 0.5, this is nothing but px of 1, so this is probability of x is equal to 1. So similarly you will get that. So basically if you write again, so this is px of 1, this is probability that x is equal to 1, you have to sum of all the yj value, the joint probability mass function keeping 1 here fixed, yj can take value 2 value, 0 and 1, so pxy of 1 0 plus pxy of 1 1. So this is nothing but second row sum. So here it is second row sum. So this is 0.1 plus 0.4, this is 0.5. So now this is the probability mass function of x is equal to 1 equal 0.5, x equal to 0 equal to 0.5. This is given from the problem, actually directly it is given. Now joint probability, and also we check that from our joint probability mass function also it is coming the correct answer. So what it is given, we are getting back. Now joint probability, the marginal probability mass function of y, how we can find? The marginal probability mass function of y is, so actually we will find p of yj. So there are two values of y it can take. First we will find y is equal to 0. How we can find? We can take the sum of the xi values, fixing this coordinates same. So this is nothing but pxy, xi can take two values, 0 0 plus pxy 1 0. So pxy 0 0 plus pxy 0 0 plus pxy 1 0. Then if you take this sum here, so this sum is nothing but 0.55. So this is equal to p of y 0, that is probability that y is equal to 0. So this is the 0.55 we are getting. This is marginal probability mass function. So similarly we can find p of y of 1. This is the second column sum. This is nothing but summation of xi, pxy of xi 1. So this is pxy of 0 1 plus pxy of 1 1. So then you can see that pxy of 0 1 is 0.05 and pxy of 1 1 is 0.4. So it is coming 0.45. So then this probability is nothing but 0.45. So we can write, so another step. So this is nothing but, this is equal to 0.45 plus 0.1, 0.45 plus 0.1, so 0.55, and this is 0.05 plus 0.4, 0.45. So note that it has to be probability mass function. If you take this sum 0.45 plus 0.55, this is equal to 1. So this sum, it will be 1, and similarly this sum also 0.5 plus 0.5, this will be equal to 1. So this is marginal probability mass function we found as per the questions. Are xy independent? So to check that x and y are independent or not, what do you have to check? So if x and y are independent, then if x and y are independent, then pxy of xi comma yj can be represented as the product of their marginals, xi into pi yj for all xi and yj. for all xi and yj. Now if it is true, let us consider some of the values. Let us take, suppose consider xi is equal to 0 and yj equal to 0. Suppose pxy 0 0. So what is this value? Pxy is 0 0. Pxy 0 0 is 0.45. Pxy 0 0 is 0.45. So if it is equal to px of xi into py yj, pxy of 0, pxy of 0 is 0.5 and py of 0 is 0.55. Py of 0 is 0.55. So this should be equal to this is px of 0 0.5 into 0.55 py of 0, py was 0. So it is very clear that 0.5 you cannot represent by 0.5 into, because if you can multiply it and then you can see that this is not equal to 0.45. So hence this is not equal to this. This is px of 0 into py of 0. Hence x and y are not independent random variable. So hence x and y are not independent random variable. So I hope you have understood it very clearly. So now find the mean and variance of x. Now we have to find mean and variance of x. Now we have the marginal probability mass function of x. We know that marginal probability mass function of y. We will use those marginal probability mass function and we will find the mean and variance of x. So this is for practice. So we have already discussed how to find mean and variance. So here for these cases we know the marginal probability mass function. Suppose we want to find the mean and variance, so we know how probability mass function px is defined. Px of xi is equal to 0.5 whenever xi is equal to 0 or 1 and 0 otherwise. This is the probability mass function if you want to represent properly. And similarly and also p of yj is nothing but 0.55 if xi is equal to 0, yj is equal to 0, and this is nothing but is equal to 0.45. So you can see that 0.45. Y is equal to 0, it is 0.55, and y is equal to 1, this is 0.45 if yj is equal to 1. So this is the probability mass function of yj. Now if you want to find the and otherwise 0, this is 0 otherwise. Basically both are Bernoulli random variable with here probability p is 0.5 and here probability p is 0.45. if you can remember the Bernoulli random variable. Otherwise you can use this probability mass function. So now what will be the mean? So expected values of x will be summation of xi px of xi over the possible values of xi. Now xi can take the two values 0 and 1. So this is nothing but 0 into px of 0 plus 1 into px of 1. So now this is 0 plus 1 into px of 1 is 0.5. So this is nothing but 0.5. Now for finding the variance we have to find the expected values of x square. So this is the in our definition mu1 dash. We will write notation mu1 dash x because it is related to the variable x. Mu2 dash x, this is expected values of x square. This is summation of xi can take 0 and 1 xi square by definition px of xi. This is the definition, which is equal to 0 into 0 square into px of 0 plus 1 square into px of 1. So this is 0 plus 1 into px of 1 is 0.5. This is equal to 0.5. So mean this is the mu2 dash x. So hence we can find what will be the variance. Hence variance of x is mu2 dash x minus mu1 dash x whole square. So you can we know that variance of x this is the simplified formula. We always use this formula. So this is mu2 dash x is 0.5 minus mu1 dash also same 0.5 whole square. So then you can write 0.5 into 1 minus 0.5. So this is again 0.5 into 0.5. It is nothing but 0.25. So this is the variance of x. So similarly we can find the mean and variance of y also. So what will be the mean of y? So expect mu1 dash of y. This is expected value of y. This is by definition summation of yj, py of yj. Yj can take the two value 0 and 1. Now we know that 0 into py of 0 plus 1 into py of 1. So this is 0 plus what is py of 1? Py of 1 is yj is equal to 1, then py of 1 is nothing but 0.45. This is 0.45. This is equal to 0.45. And then similarly we can find expected values of y square. This is mu2 dash y. This is expected values of y square. So this is nothing but summation of by definition y square p of yj. What are the possible values of yj it can take? Yj can take 0 and 1. So this is 0 square into py of 0 plus 1 square into py of 1. So this is 0 plus 1 into py of 1. Already we know that this is 0.45. This is nothing but 0.45. Hence variance of y. Hence variance of y is nothing but by definition. So definition we defined y minus mu y whole square. So this is simplified form is mu2 dash y minus mu1 dash y whole square. So this mu2 dash y is 0.45 minus 0. Mu1 dash also same 0.45 whole square. This is nothing but 0.45 into 1 minus 0.45. So this is 0.45 into 0.55. So whatever the value it will come, just you can compute and numerically you can find the variance of y. So that you have to compute and you can find the value. So this is the find the mean and variance of y. So we can find. So I hope you have understood it, that how you can find mean and variance of x and how mean and variance of y in this problem. Find the covariance of x and y. So this is new. So earlier we have computed all these terms. So just we repeated it for this example. All these definition we know and we have used the definition to find these values. Now we will find the covariance of xy. So for finding covariance of xy, what is the formula for covariance of xy? So the covariance of xy is given by, so we say covariance of xy, we denote by sigma xy. This is expected values of x minus mu x, mean y minus mu y. So we have some simplified formula. We have already shown that it can be represented as expected values of xy minus mu x into mu y. What is mu x mu y? Mu x mu y is simple. They are first order raw moments. This is mu1 dash x into mu1 dash y. That we have already computed. Mu1 dash x is 0.5 and mu1 dash y is 0.45. Already we have computed. Now we want to find what is expected values of xy. You have to find. So expected values of xy. This is equal to by definition it will be summation of xi can take 0 and 1 and yj can take 0 and 1 xi yj pxy of xi into xy comma yj pxy of xi comma yj. So summation of yj equal to 0 yj 0 to n 1 and xi also 0 to 1. So then we have to find out. So this is 0 into 0, all these value possible value pxy of 0 0 plus 0 into 1 into pxy of 0 1 plus 1 into 0 into pxy of 1 0 plus 1 into 1 into pxy of 1 1. Note that other probabilities actually whatever the value we need not to compute because it is multiplied with 0, this becomes 0. So this is 0 plus 0 plus 0 plus 1 into 1 pxy of 1 1. So let us go back and find out what is pxy of 1 1. This is 0.4. pxy of 1 1 is 0.4. So this is nothing. This is 0.4. So this is 0.4. Now just we'll replace it in this formula, all this value. Hence covariance of xy, sigma xy, this is equal to expected values of xy minus mu1 dash x into mu2 dash x. So mu1 expected value of xy is 0.4 minus mu1 dash x is, so mu1 dash x is just mean of x, this is 0.5 here we have computed 0.5 into mu2 dash x is here, mu2 dash y, sorry, mu2 dash, it is not x, it is a mistake. So this will, no, this is correct, mu1 dash is just a mu1 dash y. So mu1 dash y will be here, mu1 dash y we have 0.45, so this is 0.45. so then you have to just compute it, 0.4 minus, it looks like 5, so maybe it is like this, 455, so 0.225. so yeah, I think it is correct. You have to just check whether this will be 5, 7 and 0.175. so please check that whether this computation is correct. So basically you have to simplify this, it is just remaining this, you have to use, you may use a calculator also, and to find that what will be the value. This is the covariance. So we say it is positively correlated, this covariance value is positive. So now next, any remaining any questions? So this is covariance of xy, you find the correlation coefficient of x and y. So this is the last question, find the correlation coefficient of x and y. So the correlation coefficient of xy and y is given by, so let us do solve it here. So the correlation coefficient of x and y is given by, so it is denoted as, you know, that rho xy, or we sometimes denote rho of xy, defined by covariance of xy by root over of variance of x into root over of variance of y. So covariance of xy we found 0.175 maybe, so 0.175 by variance of x. What we found? Variance of x, we found that variance of x, here we computed variance of x is 0.25. so this is square root of 0.25 into 0.25 into then variance of y. Variance of y, where is that? Variance of x 0.25. Variance of y actually we did not compute, we have to multiply this, so then you will find the variance of y. So if you use a calculator to compute it, you can see that you will get the value 0.45 into 0.55 equal to 0.2475. This is the variance. So then 0.2475 we will replace here, square root of 0.24, what I found, 0.2475. So then you can simplify. So just remaining thing, you have to just compute it. You can use a calculator to do this. So finally this is 0.175 by root over of 0.25, or you can write square root of 0.25 into 0.2475. so this is equal to 0.25 into 0.2475, so it is coming 0.175 by square root of 0.061875. This is equal to 0.175 by square root of 0.061875. 0.61875. This is 0.2487 approximately up to this decimal place, 0.24875, which is approximately equal to 0.175 0.24875. So 0.7035. So it is approximately up to 4 decimal place 0.35. So if the other computation are correct, so then this value it will come like this. So please go through again. So this is just remaining part is you have to just compute it and you have to check what are the value it is coming. So I have just used some simple calculator, and then I found this result. So you please check that whether if there is any mistake, so you please correct it. So otherwise this is the method of finding the correlation coefficient. So here you can see that if this is correct, then the correlation coefficient are positive. So it seems whenever correlation coefficient positive, we say that x and y are positively correlated. If correlation coefficient negative, then we say that x and y are negatively correlated. And if they are close to 0, then we say these value x and y are uncorrelated. So this is the concept of covariance and correlation coefficient and the interpretation. So I hope you followed it, you understood it very clearly.